Today I am going to present a use case that I also presented at Semtech in San Francisco in 2013, and we used these opportunities to record them so we can put them on other places. So what I'm going to talk about today is about a use case and a product that we've built for the construction industry to help construction industry with their risk problems, and in a minute I'll tell you what those risk problems are. And then we have this solution where we have a collaborative tool for issue tracking in large construction projects. So in the software industry, we have bug tracking systems so that anything goes wrong in the developer of a product, we always have a record, and all the information in the project is centered around these bugs. But in the construction industry, everything is done in email, and so there's not even formal issue tracking system. So that's the first tool that we built. Then the second thing that we built is a fast federated email search in the cloud. So if you are in a large construction project with hundreds, potentially thousands of people all working, all sending emails to another, then when you want to find, when something goes wrong and you have to do your forensics, and you then it can take literally hours to find emails back. And we created a system where in seconds you can find emails in literally millions of emails. And then what we also have done is we created technology to link emails to your document system. And by that, the documents, I mean your contracts, your smart schedules, your design documents, project progress reports, etc., etc. And ultimately, that's all available in a risk dashboard where people in the owners of construction projects or construction people at any point in time can see the risks that they're going to run in the near future. And under the cover, we use technologies like Solar and Logograph. We have new technologies to create ontologies out of contracts and design documents and schedules. We work with semantic indexing of emails and documents using ontologies and taxonomies. And I'll talk a little bit about how we analyze it with pattern recognition technology. Okay, so this is the overview of my talk. What is the problem in the construction industry? Well, here's a slide that I'm not going to read to you, but just wanted you to notice that the total global construction demand is estimated to be 24 trillion to 13.5 trillion through 2030. So this is enormous, enormous numbers. Just look at this picture here, how the developing countries are coming up and spending more and more money in this area. So it's a big problem. If you just look at this year, at any point in time, there will be more than 16,000 projects over $50 million. And here's the key. 75% of large construction and infrastructure projects suffer unexpectedly legal costs equal to more than 20% of the total project value. So 20% of this 2.1 trillion is going to be paid to lawyers. So it's an enormous amount. And if you can save anything there, you just have, well, you can make a big, big contribution. Now, why is it so expensive to do these legal projects? Well, just look at the money you spend on lawyers once something goes wrong. I mean, I don't think there's many people in this audience that are making $1,000 an hour, but if you're a lawyer and something goes wrong in a big construction contract project, then you'll pay these amounts to the people. Now, where do the costs come from? Let's say you start a huge project, and real soon you have more than 100 vendors, and all these people are communicating with each other in email, and the project managers of the construction project get most of these emails. And then at some point in time, something goes wrong, and you already have millions of emails. So then what happens usually is you do e-discovery, so you try to get all the emails together. You get a war room, and then a bunch of lawyers and other people will sit there, sift through the emails to find the things that will prove your point or disprove the other people's point. And the point is that on both sides they're doing the same game, because both sides play the game. And then once you figure out all your well, once you've figured out where things might have gone wrong, then you go into in front of the judge, or you try to mediate. But again, that costs a lot of money. So what you see that is many cases are settled anyway. And so our approach is to, at any point in time, make it much easier to track emails and documents and link them all together so that we can proactively avoid risks instead of doing it afterwards. So what are the problems for the people in these big construction projects? If you look at the C-level executives, so for example, the investors and owners, and their problem is they have almost zero visibility in the contractual risk. They don't know where they are at risk. If something bad happens, they don't know how it relates to terms in the contract. They can't look very far ahead in time to see where problems might pop up. And then if these guys start a new project again, they lost all the knowledge that they built up in the last big project, because all these big construction projects are mostly like virtual organizations that get started when the project started and then dissolves when the project is over. So there's no institutional memory. Just by looking, and let me give you just one idea. So you're the owner and you have requirements of the thing you want to build, say a nuclear power plant. Well, while the project is going on, you want proof that everything is designed and built according to requirements, But requirements and most engineering data are still implicit and unstructured. This applies to the contracts. All of your documents, drawings, your memos, the work breakdown structure, the system breakdown structure, all or most of it is just completely unstructured. And then obviously all the internal project communication is done by email. It's not linked to any requirements, and it's again all unstructured. So that's a big problem. And here's the kind of things that you would like to know: is once something goes wrong, is who gave the first indication that this requirement would not be met? Or what is the general mood regarding all the emails for this set of requirements? And I'm not going through the rest here, but we came up with a long list of questions that people just might ask about requirements. And anyway, so let me continue. Now, say now you're a project manager in a big contract. Well, you're in a new virtual organization. You can have sometimes more than 100 plus vendors if you, say, build a nuclear power plant. 99% of communication through email. So these project managers get more than 300 emails a day. And their problem is that every email can be a time bomb. I mean, say you get an email in that says, hey, the door will be 2 days late. That's not a problem, isn't it? Well, you can't say yes. I mean, the lawyers teach you not to say yes in this case. But you have to now go to your design documents or your schedule to figure out whether the door is indeed too late, and this is very important, whether or not you should send out a notice to the other party that they're in trouble. So what you see in most contracts, that if something goes wrong, you have about 7 days time to complain in the notice. Otherwise, you can't later get back to it. So even a little simple email like, the door will be 2 days late. It's not a problem, yes, is already a time bomb. So you have 300 of those a day. And so the problem is your project manager and your emails are not linked to all these contracts and design documents because they're just digitally unstructured blobs. So, and then there's no issue tracker. So you can't hang this email about the door to any issue that you already might have. Or maybe you have to start a new issue. So that's your problem as the project manager. And we talked to a bunch of them. And what all these project managers say is, hey, I can't do my work just because of all this email that I have. Then say you are in a big construction project. There's always a legal team associated with these projects. And you have risk managers. But of course, these people can't read all the emails where people communicate over potential problems. And again, they're unlinked to all the documents that you care about. And then the problem is, how do you fight your opponents if they have better systems for recording than you have? So that's why we build our solution, where the blue parts are in production and the red things are things we're working on right now. And our solution is a cloud-based contract risk mitigation platform that automates the early detection of risk in large construction projects. As I said before, it's a collaborative tool for issue tracking. It's a very fast email over hundreds of mailboxes going back several years in a row. And we linked all emails to all the documents. Basically now just using simple taxonomies, but in the near future also very, very advanced linking through analyzing contracts and schedules. So that's the solution that we have. And if I have to summarize it, I would say, well, we turn every document into a set of objects represented as triples or graphs. Yeah, so here's all the types of things. And then we semantically link every email to all available documents. And partly we do that automatically, and partly we can do this with manual tools. And then once we have that, we are developing algorithms. We have algorithms. We can predict non-delivery delays and other risks. And the metaphor that I like to use is if we now take any fragment in the document and we lift it up, then we get all the associated emails. Or if we take any email, we find all the related fragments from the documents that we're interested in. So this is just a tiny example of how this looks like. So here you see part of a lease flow, and you see, so this is normal unstructured text, but we turned it into triples, and you see that this is in the context of a company building a robotic car. Yeah, where you see that someone needs to lease something, you take possession, you pay the rent, and ultimately you give your thing back. Well, this is everything okay? This is all the exceptions modeled as a graph. And again, this is not the time to go into detail, but you can check later on the slides how all the things that you, well, now let me take a step back. It's like a computer program. Yeah. If things go right, you get the main algorithm, but most of the time, 80% of your code is for error correction, and what if things go wrong, or the same thing in contracts. So let me talk about these 5 parts of a solution in very short detail. At the lowest level, there's a collaboration tool for issue tracking, where people in the field can say, hey, I expected the door, but it's not there. They can send it to a project on a website, on a SharePoint website. They can say, oh, I saw something that might be wrong. Then the project leader decides whether or not he wants to percolate it up to the legal experts that then can decide whether or not it's going to be a claim, a separate claim on the collaborative SharePoint website. And then on top of that, there's dashboards. So at any point in time, people can see where all the claims are and what the total number of money that is potentially involved to deal with these claims. Yeah, and so here's a little bit of the website where you have your issues, your discussion boards, and at the top a dashboard where you can see for each of your projects whether you're in the plus or whether you're in the minus. So that's the first part. Second part was this fast, faceted, federated email in the cloud. So what we do is we take your Outlook Exchange and we take all in and outgoing messages and forward them to the cloud. Then in the cloud, the metadata about your emails, so the headers, but also the links to documents are stored in a Lego graph, and the body and attachments are in Solar. And because people don't want to do Sparkle queries, we created an Outlook plugin for faceted search. And then we started out with the taxonomy of all the words that lawyers find important. And so we also indexed all emails using those danger words. And I'll show that in a second. And then, of course, not everyone can look into this email. So we have an access control list so you can determine who can see what emails. Yeah? So just to show you a little bit of the underlying data. Let's see if I have that here. It's not here. Oh, yeah, here. So I have, let me make it a little bit smaller. So here we have a Lego graph looking at the database. In this case, because I can't demo real actual data, we have about 500,000 emails from the Enron case. Most people are probably familiar with that. And what you see here is that we do a Sparkle query against a database of emails, a lexicograph in Solar, where we say in Solar, find all the emails that have danger words, and there's about 300 words in this line, and then where these emails have come from Enron and go to a company that's not Enron, and when we execute that, we get here a list of the emails. So this is the underlying technology, but of course you'll never give this to your end users, so we have another tool. Let me show that here. Is not it. Go here. I thought I had it ready. Okay, so this is a demo of our Outlook plugin that talks to a database. So basically, what you do is you start a query. In this case, I want to make a new query. And in this new query, we're going to look for arbitration. So we want to find the emails with arbitration. And we only want to look in the body. And then we decide all the facets that we want to have after we get the first return set, so we can drill down in our return set. And we want to save this query, so we can go back to it later. This is, of course, a very simple query. And once we have that, we get our results back. So what you see is that we get about 2,083 records that all contain the word arbitration. And notice that this is in about 150 different email sets. Yeah, it was just a second to get it back. But say we want to only look at the things that have agreement in the word in the text. So now we drill down and look at the 199 emails that have agreement. We have that, and now it's still too much. So now we could go back again to the faceted search and look here and say, well, maybe we also want folio as a word. So now you look again. Now you have only 37 records. You get the idea. I'm stopping the demo right now, but the main point is that we can search in this case, in hundreds of mailboxes, get results back in seconds, and then have a very convenient mechanism to drill down in the total set to get down to the lowest number that you need. Yeah, so that's the first little demo that I wanted to give. Then we go to the third part of the product, where we semantically linked emails to documents. So what we did is we created basic vocabularies and taxonomies for all the documents, which is quite some work because there's not many readily available taxonomies in the construction industry or taxonomies available for contracts. And what we do is we split all the documents into fragments and chapters and paragraphs, or for design docs in triples, in step XML turned into triples. For schedules, we also use XML and turn it into triples. And then we can do automatic indexing, but in case there's ambiguity or the system can't find links, we also have the opportunity to link emails to documents using expert intervention. So here's a tool that we use called Semaphore to make these taxonomies. So here's part of the taxonomy for a contract. And then we have this tool called a manual tagger, where we can look at a particular email, we can highlight part of the email, and then link it to an ontology that we have here. And once we have linked it, then we could take any part of the ontology and say, give me all the emails that are related to it, or vice versa. So by the way, what you see here is that the blue ones are the things that you did yourself. The green ones are the things that were automatically recognized. Yeah, so this is the third part of the product. Then here's what we're working on right now is smart contracts. Yeah, because just doing semantic indexing on contracts is not enough to understand a contract. Yeah. So what we have to do is to create a real ontologies out of contracts. where ontology is a collection of, say, physical objects, actions, requirements, organization, people, costs, etc., etc. So ultimately, what you want from a contract and all the information linked around it is you turn it into this ontology. Here you see an ontology of contracts. Look at the thing, which is tasks or events. It can be tasks or legal entities or documents. And then you use that ontology to look at the contract and take the most important parts out. So here you see from a contract the four main phases. And then for these phases, you see who's actually executing this. So you see a company called Acetex and Codebase that are vendors that have sub-vendors here. Here's a part where we take a contract, and again, this was part where we did an automatic conversion, where we said without payment or approved specs, and the next step is to purchase the vehicle. And then we bring the vehicle to some place, and then we make some modifications, etc., etc. Yeah, so this is, again, part of a contract that was turned into triples. And so now the question is, how do you turn these contracts into triples? Well, there's two ways we can do it. We can use some kind of natural language extraction that we've developed, or we can use a wiki-like approach, where we turn a contract into a set of objects that are directly accessible in a wiki-like structure. And so we use for that kind of a symbolic spreadsheet in the form of a wiki. It's used in many places, where the wiki has all these entities already for this kind of objects, and where you can start, say, with a tunnel, that has an entrance, and there's some sustainability requirements, and there's environmental impact, and then there's a person that's responsible for something, and you keep going, and you're building up a total network in your wiki structure of things that are connected, and ultimately you get a set of triples where partly it's requirements management, partly it's about the organization in the contract, it's about documents, verification, system breakdowns, work breakdown structures. Yeah? And here's a screenshot of this wiki structure that we use. For example, the wiki for a requirement that you then can link, say, to an organization or to a person. So a very handy way, but kind of time-consuming to do that. So it would be better if you could use NLP. So here, let me show what we did with as an example. So we take a basic non-disclosure agreement. Yeah. So this is the text, and when our technology is done, we've turned this entire non-disclosure into a set of triples. And we use this. We start with an input sentence. Yeah, that's just natural language. We normalize it, turn it into smaller sentences, then apply a pattern language that's built in XML that covers, say, something. These something must commence something within something days from something. And so we write thousands of these patterns that are the most common in documents, and then we deal with the stars in here. We say what kind of objects they have to be, and ultimately we create here new kinds of triples at the bottom. And then this is, again, the result that you get out of this. Now, say you have your emails, and you have them all in one system in Lego Graph and Solar, and you have your contracts, and you turn them all in triples. So now how do you link them automatically together? So for that, we wrote a set of business rules, and just to give you one example, this would be a business rule where you say, well, if an email E contains a person P, yeah, so this email contains a particular person, and this person P is responsible for a particular task, yeah, and then there is a clause that contains this particular task, then link this particular email to a particular contract phrase, a contract C. So at the end there will be a direct link from email to this phrase of the contract. So in conclusion, we can use semantics to model risk. And risk is everywhere. So we've applied this in the construction industry, but we could just as well use this in the pharmaceutical industry or any other industry. And again, if you want to know more about this, just contact us, and we'll start talking.
Okay, are there any questions from the audience?
How does Solar integrate with the Lego graph? So it's built into a Lego graph right now, where if you have documents that you want to index but also have the net information in the Lego graph, then what you do is you take the documents, turn them into Solar documents, but you make sure that Solar documents have at least one unique ID that we can also use in the tuple store, and then we can, in Sparkle, Sparkle 1.1, as I showed you before, do Sparkle queries where we talk both to Solar and Sparkle at the same time. Another question, how long would it take for us to develop a taxonomy for our use case? Well, there are tools where you can take a document, and then these tools will automatically determine all the new words that you don't have in your taxonomy yet, and then you can drag them and start organizing your taxonomies, or you can build it from the ground up. But if you go into a new industry, it's definitely going to take several months, up to a half year, to get your first usable taxonomy that covers, say, 99% of what you want. And we help customers with building these taxonomies. Okay, well, I think those were the questions. Thank you very much.